Welcome to RPS video tutorial again. I am representing a program which will accept two values from the user, lower limit and upper limit, and the program will display all Armstrong number between two values. As include stdio.h io.h void display arms, an user defined function which will be called each time, and the function will display Armstrong number. Actually it will check the values, and if it is Armstrong number then it will display, otherwise the control will be returned directly to main functions if the number is not an Armstrong number. Then main lower upper high printf enter a lower limit number %d address of lower and upper limit number scanf %d address of upper I equals to lower, I less than equals to upper. Loop will be started from lower and it will continue to upper I plus plus, and within this loop the display arms function will be called. Display arms I. Get ch end of main. Okay, void display arms intn int sum equals to 0, d equals to 0, temp I and j, and also one variable more will be used, p equals to p. Count number of digits while n, and before starting the loop assign the value of n into temp equals to n, because after completing this loop n becomes 0, and so temp will be used after completing this loop. to get the original number again. While n greater than 0, d plus plus n by equals to 10. While n equals to 10. Suppose n is 100. Then after completing this loop, n will be 0. But temp will hold that number. So if we assign the value of temp into n, then n will get the original number again, in which we can work with n again. While n greater than 0, j equals to 1, p equals to 1, and r, another variable, will be used to retrieve the remainder, that is the last digit of number each time. r equals to n mod 10, while j less than equals to d. D is number of digits which will be power of each digit. P equals to p into r, j plus plus sum equals to sum plus p. Each time the final value of p will be added with sum. n by equals to 10. If sum equals to temp, if both numbers are same, then display the value of n in the percentage d n, otherwise not. If this condition satisfies, then display the value of n, otherwise control will return back. Okay. Let us see what is the logic behind it. Suppose n is getting 153. Here 153 greater than 0, this loop will continue 3 times, because each time n will be decreased by 1 digit. N equals to n by 10. Significance of this line, n by equals to 10. Actually here we have used assignment operator by equals to, and actual meaning of this, n equals to n by 10. And so each time n will be decreased by 1 digit. Suppose 153 by 10, n will become 15. Next time 15 by 10, n will be 1. Next time 1 by 10, n will be 0. Loop will be stopped. And again we are storing the value of temp into n, so n becomes 153. Again this loop will be started, and actually the function of this loop is to find out the number of digits of n, and in this case d will be 3 times d will be increased. N equals to temp, n is again 153 greater than 0 condition is true, so this loop will work. J equals to 1, p equals to 1, r equals to n mod 10. R equals to n mod 10, so r will get 3 last digit. R will get 3 and j less than equals to d3 j1 1 less than equals to 3 condition is true. So 3 times this statement, these two statements will work. P equals to P into R. P is now 1 into 3, second time 3 into 3, next time 9 into 3. That means after completing the loop, P will get 27. That will be added with sum. 27 plus 0. Sum is 0. 27. N will be 15. 15 greater than 0 condition is true again. So J, P and R will be re-initialized. J1, P1, R equals to N mod 10. 15 mod 10. R will be 5. J less than equals to D. Again 3 times this loop will work. And P equals to P into R. R is 5. 1 into 5. 5 into 5. 25 into 5. That means P will be 125. And 125. P is 125 and sum is 27. Final value of sum will be 152. N equals to N by 10. N will be 1. 1 greater than 0 condition is 2. J equals to 1. P equals to 1. R will be 1 again. N is 1. 1 mod 10. R will be 1. 1 less than equals to 3. 3 times P equals to P into R will be 1. And here 1 into 1 1. Next time 1 into 1 1. Third time 1 into 1 1. Final value of P will be 1. And sum was 152 plus P is 1. 152 plus 1 153. And now N becomes 0. Loop will be stopped. And here we are checking the value of sum, checking the equality of sum and temp. If sum, then the value of N will be displayed. And here sum is 153 and temp is also 153. So condition will be satisfied and the value of N will be displayed. Each time this function will check N whether it is Armstrong or not. If it is Armstrong, then the value of N will be displayed. Otherwise, the control will go back. And here, at first we are accepting the value from the user, lower limit. Suppose it is 100 and upper limit 200. So loop will be started from 100 to 200. It will be stopped when the value of I will be 200. 201. Okay, and every time the function will be called and it will pass the value of I. First time 100 will be passed, second time 101 will be passed, next time 102 will be passed, and each time the display arms will check the number whether it is Armstrong or not. Execute the program. Result is not correct. Sorry, it will be temp, because after completing the loop N will be 0, but temp will hold the original number. Okay, these are the Armstrong number between 100 and 500. Another program, 100 and 1000. Sum.